metallic fitting accelerated aging and dielectric voltage withstand test is performed to evaluate the durability and electrical insulation integrity of metallic fittings used in power distribution systems. The test consists of two main parts: accelerated aging and dielectric voltage withstand testing. Firstly, accelerated aging involves immersing the metallic fitting in a corrosive solution, such as salt water, for a specified period. This simulates exposure to harsh environmental conditions. In addition to immersion, the fitting is exposed to high temperature and humidity to further accelerate the aging process and mimic real-world operating conditions. Secondly, the dielectric voltage withstand test involves applying a high voltage, typically alternating current, to the fitting between the conductive parts and ground. The voltage is gradually increased until a specified breakdown voltage is reached, or the test time is exceeded. The purpose of this test is to verify the insulation's ability to withstand high voltage stresses without failing. The interpretation of the results is critical for determining the fitting's suitability. In the accelerated aging portion, if the fitting shows signs of corrosion, delamination, or other damage, it indicates poor resistance to environmental degradation. The extent and type of damage are carefully documented to assess the severity of the degradation. For the dielectric voltage withstand test, if the fitting withstands the specified voltage for the required time without breakdown, it meets the dielectric voltage rating requirements. This confirms that the insulation system is adequate for the intended application. If breakdown occurs below the specified voltage limit, it indicates a potential weakness in the insulation or conductive components of the fitting. The breakdown voltage level is recorded and analyzed to identify the source of the failure. Several factors need to be considered to ensure the validity and accuracy of the test. Test parameters, such as aging conditions, including the type of corrosive solution, temperature, humidity, and duration, and voltage levels, must be carefully selected to represent real-world conditions. The selection of these parameters should be based on the expected operating environment and the potential stresses the fitting will encounter. The condition of the fitting before testing should be documented to ensure a fair assessment. Any pre-existing defects or damage should be noted, as they may influence the test results. Test results should be evaluated in conjunction with other design and performance data to determine the overall suitability of the fitting for its intended use. This includes considering the fitting's mechanical strength, thermal properties, and other relevant characteristics. The significance of this test lies in ensuring that metallic fittings can withstand the harsh conditions of power distribution systems and maintain their electrical insulation properties over their expected lifespan. Fittings that pass these tests are considered safe and reliable for use in these applications. The test helps prevent electrical failures and ensures the safe and reliable operation of power distribution systems. Let's delve deeper into the accelerated aging process. The corrosive solution used in the immersion test is typically a salt water solution with a specific concentration of salt, such as sodium chloride, to simulate marine environments or areas with high salt content in the soil. The concentration of the salt solution and the immersion time are carefully controlled to achieve a realistic level of corrosion without overly accelerating the process. The temperature and humidity levels during the high temperature and humidity exposure are also crucial parameters. Typically, the temperature is maintained at an elevated level, such as 60 degrees Celsius or higher, and the humidity is kept at a high percentage, such as 90% or higher. These conditions accelerate the corrosion process and help identify potential weaknesses in the fittings, materials, and coatings. During the dielectric voltage withstand test, the high voltage applied to the fitting is gradually increased to avoid sudden voltage surges that could damage the insulation. The rate of voltage increase is typically specified in a test standard and is carefully controlled to ensure accurate results. The duration of the test is also important. The fitting must withstand the specified voltage for a certain period, typically 1 minute, without breakdown to pass the test. Breakdown is defined as the occurrence of a disruptive discharge through the insulation, resulting in a sudden drop in voltage or a flow of current. The interpretation of the test results requires careful examination of the fitting after the accelerated aging process. Signs of corrosion, such as rust, pitting, or surface degradation, are carefully documented. Delamination of coatings or other protective layers is also noted. The extent and severity of the corrosion and delamination are assessed to determine the fitting's resistance to environmental degradation. In the dielectric voltage withstand test, the breakdown voltage is recorded, and the location of the breakdown is identified. If the breakdown occurs at a voltage below the specified limit, it indicates a weakness in the insulation system. The location of the breakdown can provide valuable information about the cause of the failure, such as defects in the insulation material, contamination, or inadequate design. The test parameters, such as aging conditions and voltage levels, must be carefully selected to represent real-world conditions. For example, if the fitting is intended for use in a marine environment, the corrosive solution should be representative of seawater. If the fitting is intended for use in high-voltage applications, the voltage level should be high enough to stress the insulation system, but not so high as to cause premature failure. The condition of the fitting before testing should be documented to ensure a fair assessment. Any pre-existing defects or damage should be noted, as they may influence the test results. For example, if the fitting has a scratch or dent in the coating, it may be more susceptible to corrosion during the accelerated aging process. Test results should be evaluated in conjunction with other design and performance data to determine the overall suitability of the fitting for its intended use. This includes considering the fitting's mechanical strength, thermal properties, and other relevant characteristics. For example, if the fitting is intended to support heavy loads, its mechanical strength must be adequate. If the fitting is intended for use in high-temperature environments, its thermal properties must be suitable. The significance of this test lies in ensuring that metallic fittings can withstand the harsh conditions of power distribution systems and maintain their electrical insulation properties over their expected lifespan. Fittings that pass these tests are considered safe and reliable for use in these applications. The test helps prevent electrical failures and ensures a safe and reliable operation of power distribution systems. To further elaborate on the factors to consider, let's discuss the selection of appropriate test parameters in greater detail. When choosing the corrosive solution for the accelerated aging test, it's important to consider the specific environment in which the fitting will be used. If the fitting is intended for use in coastal areas or offshore platforms, a saltwater solution with a high concentration of sodium chloride is appropriate. For fittings used in industrial environments with exposure to chemical fumes or pollutants, a more complex corrosive solution containing a mixture of chemicals may be necessary. The temperature and humidity levels during the accelerated aging test should be selected to simulate the most extreme conditions that the fitting is likely to encounter in its service life. This may involve considering seasonal variations in temperature and humidity, as well as the effects of solar radiation and other environmental factors. The voltage level used in the dielectric voltage withstand test should be based on the rated voltage of the electrical system in which the fitting will be used, with an appropriate safety factor to account for transient overvoltages and other potential voltage surges. The test voltage should be high enough to stress the insulation system, but not so high as to cause premature failure or damage to the fitting. The duration of the dielectric voltage withstand test is also an important consideration. The test duration should be long enough to allow any weaknesses in the insulation system to manifest themselves, but not so long as to cause excessive stress or wear on the fitting. Standard test durations, such as 1 minute, are typically used to provide a consistent and repeatable test procedure. In addition to the test parameters, the preparation of the fitting before testing is also critical. The fitting should be thoroughly cleaned and inspected for any pre-existing defects or damage. Any surface contamination, such as dirt, grease, or corrosion products, should be removed to ensure accurate test results. The fitting should also be properly mounted and grounded to ensure that the test voltage is applied correctly and that there is no risk of electric shock. During the accelerated aging process, the fitting should be periodically inspected for signs of corrosion, delamination, or other damage. The frequency of these inspections will depend on the severity of the aging conditions and the expected rate of degradation. Any changes in the fitting's appearance or performance should be carefully documented and analyzed. The dielectric voltage withstand test should be conducted in a controlled environment with appropriate safety precautions. The test area should be isolated from unauthorized personnel, and warning signs should be posted to indicate the presence of high voltage. The test equipment should be properly calibrated and maintained to ensure accurate and reliable results. After the testing is complete, the fitting should be carefully examined and analyzed to determine its overall suitability for its intended use. The test results should be compared to the relevant industry standards and specifications to ensure that the fitting meets the required performance criteria. The test report should include a detailed description of the test procedures, the test parameters, the test results, and any observations or conclusions. This report should be retained for future reference and used to inform the design, manufacturing, and quality control processes. In summary, the metallic fitting accelerated aging and dielectric voltage withstand test is a critical tool for evaluating the durability and electrical insulation integrity of metallic fittings used in power distribution systems. By carefully controlling the test parameters, preparing the fitting properly, and conducting the test in a safe and controlled environment, it is possible to obtain accurate and reliable results that can be used to ensure the safe and reliable operation of power distribution systems. Firstly, select test parameters that accurately simulate real-world conditions, encompassing aging conditions, voltage levels, and test duration. Secondly, meticulously document the fitting's pre-test condition, noting any existing defects or damage that could impact results. Thirdly, interpret test results in conjunction with other relevant data like mechanical strength and thermal properties for holistic assessment. Fourthly, recognize the test's significance in guaranteeing fittings withstand harsh environments and maintain electrical insulation over their lifespan. Fifthly, passing the test indicates safety and reliability, ensuring secure power distribution system operation. Sixthly, corrosive solutions should mirror the fitting's operational environment, such as saline for marine applications or chemical mixtures for industrial settings. Seventhly, temperature and humidity levels during accelerated aging should replicate extreme service conditions, including seasonal variations and solar radiation exposure. Eighthly, the dielectric voltage withstand test voltage should align with the electrical system's rated voltage, incorporating a safety factor for transient overvoltages. Ninthly, conduct periodic inspections during accelerated aging, documenting changes to the fitting's appearance or performance for comprehensive degradation assessment. Tenthly, all tests must be performed in a safe and controlled environment with properly calibrated equipment, adhering to safety precautions and industry standards. These measures collectively ensure test accuracy, reliability, and the ultimate suitability of metallic fittings for their intended applications in power distribution systems. Remember to always consult the relevant industry standards and specifications for detailed guidance on conducting these tests.